Hey guys, what's up? This is DeRaze and I'm back with another tutorial in the series on functional JavaScript. So let's get started, and I'll be also giving an example on recursive functions in this topic because today I'll be talking about recursive functions. So I would suggest you open up JS Fiddle and code along with me because this is a very short code, but I'll explain a lot when it comes to recursive functions in case you don't know what they are. Anyways, recursive functions are really pretty used, pretty common and very important in functional JavaScript, and they find application in various other languages as well, not just JavaScript. So let's get started. So over here, as usual, I have two document.get element by ID injections via inner HTML method. So what I do is I inject them over here into the separate divisions created over here, as you can see, with IDs box and box 2. Also, I've given a CSS styling over here in JS Fiddle, and all of this is possible in JS Fiddle because of its UI. In its interface, you have 4 different screens, as you can see on the monitor. So I would really suggest you go ahead and deal with this piece of code on this website. So let's get started. What are recursive functions? Recursive functions are very common and they are famous. They form a part of the most famous functional programming techniques. So it's a very famous one. So a recursive function, in short, is nothing but a function that calls itself repeatedly until a result is achieved. So you might generally hear from people that programs run into infinite loops and all that. So one major reason that might be because the recursive function was not given an end case. So we'll be seeing, I'll explain what it is in the example given below. I'll highlight it as of now. Okay. So anyways, let's get going. So we have the third point, which says that loops can be rewritten in recursive style a lot of times. What this means is that there is another way where people generally work with repetitive tasks, which is using a loop. So you might come across loops in your C programming or other languages where they use for loops, while loops, do while, and for each loops in certain other applications. So in other programming languages. I'm sorry. So these loops can be rewritten in recursive style. So it is suggested by a lot of programmers in JavaScript to write your pieces of code in recursive functions. And why is that? Is because in recursive functions you don't use many variables as you tend to use in loops. So it is generally recommended by these folks. Anyways, the fourth point says that they are most effective for solving problems involving iterative branching, like fractal math, sorting, or traversing nodes of nonlinear data structures. So if you come across data structures, you might see something called trees. So trees are generally what I would describe to be an upside down tree actually, or what you can say is that one data contains 2 different nodes. So you might come across these if you read about data structures and algorithm design and all those. So in these trees, what happens is that when you solve problems related to trees, so you'll be using recursive functions over there, and the generic programming with loops and all fails over there. So sorting and traversing nodes is what is called the traversal of nodes is what is called as dealing with trees. Anyways, so we have fractal math as well, which is coming up these days quite often. So these things can be used by worked with by recursive functions. So go ahead and learn them, and also listen to this video completely. Alright, next, the fifth one says that recursion is favored because the code doesn't require local variables, as I was telling you. You can see down below that local variables aren't used. Other than the fact that we give certain we give parameters to define our function, we don't use any other local variables. So you'll be seeing that. So what this does is it doesn't it saves you time though it takes up some stack space, and stack space is what happens when you have recursive functions. So one function calls the other function calls another function until, and this process keeps going on until your end case is reached. So what happens is that in the memory, the stack keeps building up, and there is a way out. To even deal with this. This is called tail call optimization, as you can see in the 7th point. So I'll be talking about that as well in brief. And 6th point says that it is easy to test because these are written in a pure manner. And when I talk about pure, what I mean to say is that we talked about pure functions in the very first video of this series. So go out there and check it out. So pure functions, as you know, are functions which don't give out side effects and which just take an input and give an output, and these outputs are always consistent. And it says that recursive functions are pretty pure. So anyways, let's get to the next point. So tail call optimization is a way where you can deal with these stack building up. So what I've written is over here is that recursive function calls create havoc on a stack, and it is easy to run out of stack space. So TCO is a way one can create a recursive style algorithm using constant stack space. So what happens is that instead of returning the values and building up a stack, a tail call optimization technique, what it does is that it just runs the next function and it keeps running it until your data collection is done, until the total the processing is done, and in that way your stack space is saved. So we'll be talking about that in other videos, so I'm saving it for that for later. Anyways, the 8th point is pretty important. So ES6 has recursion support and it still needs to grow. So anyways, ES6 is the ECMAScript 6. So it is the new regulation. So it has recursion support and it really supports functional programming. That is why I'm making these tutorials. Anyways, let's get to the example and close this topic quickly. So first I'll remove the comments over here. Alright, so I uncommented it. So as you can see, we have a variable called a function called total sum. So I built it using the function operator. So as you can see, variable total sum is equal to function n, and in this you have these so-called actions happening. So let me indent it. Alright, okay. Alright, so as you can see, what happens is that if n is equal to 0, return 0, else return n plus total sum of n minus 1. So as you can see, there is another function over here in the return statement, and that is nothing but the same function over here. So as you can see, return n plus total sum n minus 1. So what this function does is that it sums the total of the natural numbers starting from 0. So if you give out let us say 10, it will give you the value of 1 plus 2 plus 3 plus 4 plus until 10. So let's test it out over here. Let's say 4, and I'll run it and let's see what happens. Alright, so as you can see, we have 10 over here, and let's count it out. So 1 plus 2 will be 3, 3 plus 3 will be 6, and 6 plus 4 is 10. So as you can see, we have the right answer over here, and there is another way to build this. Basically, we have other ways as well, it's not just one way. So we can build it using a loop where a counter is placed and the counter can keep counting down, or else you can place a while loop. So while loop will evaluate to a test condition. So over there you don't have to put a counter, but this function which I created over here relies entirely on a recursive function, recursive styling. So this is one pretty good example for you guys, so you can go ahead and test it out. I really strongly suggest that you use JSFiddle as I keep going ahead. Alright, so as you can see, we have the sum of n natural numbers, a piece of code over here. You can also count what is the 1 plus 2 plus 3 until 10, which is 55. Also you can count what it is till 100 and it will give an answer. So similarly you can keep going, so you can even ask till 1000, you can give what it is till 3, 4, 5, 6 and it will still give you an answer. So as you can see, it is working pretty fine. So this is how you can go ahead and deal with your various iterative functions. So I strongly recommend that you read about recursive functioning, recursive functional programming. I'm sorry. So anyways, thanks a lot for watching. That's it for this video. I'll see you in the next video. So I'll be talking about various other elements in the functional programming. Until then, stay tuned and also share this video with your friends and tell them about these videos so that they also learn functional programming. And also give it a thumbs up if you like this video. And I'll see you guys in the next video. Thanks a lot for watching. Bye bye.